Hello and good afternoon, and welcome to what we can consider to be part 3 of this Layer 2 Tunneling Protocol version 3, or L2TP v3 demo. There's 2 previous videos. The first video showed the L2TP v3 setup with a dynamic configuration where you were not manually configuring the L2TP settings. And then we even did a second part to that where we added IPSec on top of that to secure the L2TP v3 tunnel between our endpoints. And now here we are again. We're going to go ahead and do a manual configuration of L2TP v3, and we're also going to go ahead and drop IPSec on there as well. And so really the major difference between the dynamic version of L2TP v3, which in probably 99% of the cases is going to satisfy the specific requirements to get you set up and running, the manual L2TP v3 configuration requires you to go ahead and set a number of manual settings. And so as you can see, I'm right here on router 4, and again, this is identical to the previous configuration. So the only routers that have been cleared are router 4 and router 6, because router 4 and router 6 are where all of the configuration work with respect to L2TP v3 needs to be accomplished, as well as the IPSec piece. All right, so let's jump right in. As you can see here on the right-hand side, I've increased the font size a little bit and bolded the R4 configuration commands all the way down through the IPSec. So what I'm going to do for R6 is I'm going to cut and paste section by section, and we'll talk about it. But for R4, we're going to go ahead and walk through the configuration and kind of discuss a little more in depth as to what some of these configuration variables that we're manually going to be adjusting represent inside of the L2TP configuration. So let's go ahead and jump right in from user exec to privilege exec and into global config mode. So the first thing we'll do is set the host name to R4. We're going to go into interface FA01, and we're going to assign the IP address of 209.165.14.2, and this is a class C address. And we're going to bring the interface up. And again, we should see a message here. It tells us our interface is up. And we're going to go ahead and go into FA00 and do a no shut. Of course, we come back into that interface a little later, because that is the interface where we're going to set our XConnect statement for our Pseudowire. All right, so now I'm going to go ahead and go in loopback 44. We're going to create the local loopback address here. IP address 4.4.4.4. And we'll do a /32, and then we're going to exit, right? So now we're going to get into the L2TP class configuration, and you're going to see some additional commands. If you remember from the dynamic configuration with L2TP v3, really the only thing that we configured was the authentication to add a little additional protection to the L2TP connection, right? So we're doing authentication at either end, and it was in that video where we had misconfigured the password and we had to do a debug in order to see that the 2 ends of the connection were not communicating and authenticating properly, and then we reset the password and that issue went away. So here we're going to take a look at some additional commands. So L2TP class, and this is going to be New York, and v3 class. And now we're in the sub-configuration menu. So if I do a question mark, you can see we still have an option for authentication, but we also have some other options as well. So the first option that we're going to do is going to be the retransmit, and underneath retransmit there are 3 options: initial, retries, and timeout. And so if you look at the first one, which is the first one we're going to change, the initial retries, it says SCCRQ message retries or timeout settings. And so the SCCRQ stands for Start Control Connection Request, right? So Start Control Connection Request. And those are the initial messages that get sent back and forth between the L2TP peers. So in this case, router 4 and router 6. And what we're saying is we're going to go ahead and set the retry timeout setting. So retransmit initial, and we're going to set the retries, right? The number of retries. So this is going to be the maximum start control connection request transmissions, right? So this is going to be the maximum number of times that it retries before it simply fails. And so we'll go ahead and set this to 60. All right, the next one is going to be retransmit, and we're going to do retries. And this is the number of retries before tearing down a control connection. And so we'll go ahead and set this to 60 as well. And then finally, the retransmit timeout max. And there's a minimum and a maximum timeout. So if I did max, you can see it's between 1 and 8 seconds. And so the retransmit timeout max we'll say is 8 seconds. Okay, the next thing that we're going to set is going to be the cookie size. And the key with the cookie is, so what is the cookie? It's the analogy of it's the same thing as what you would have with HTTP or HTML code doesn't really stand up. So really what we're looking at with a cookie is the maximum size of the cookie. It can be 64 bits total. And what it's used to do, the cookie is used to check the association of the data messages that go back and forth. And real quickly, there's two types of messages that L2TP v3 is going to exchange, and they're either going to be control messages or they're going to be data messages. And so the cookie is used to check to see that the data message is associated with the session ID to make sure, it's just one more check to make sure that the data messages are going to the correct session, right? So that they're getting to the right place. And that's really what the cookie is used for. So we're going to go ahead and set our cookie size, right? And this is simply the size. You have two choices. You can have a 4-byte receive cookie, which is the 32-bit. And again, remember we said the max is 64 bits, so we would set that to 8 bytes if we wanted it to be 64 bits in size. Again, as you can see, unless you've got some very extenuating circumstances, the default, right, or the dynamic L2TP v3 setup is probably going to suffice for what you're trying to do. All right, so we've got our cookie size set up. Let's go ahead and get our authentication in here, and this is where we ran into issues yesterday. And so we're going to set our password to Cisco, and then we're going to exit out. All right, so now we've defined the L2TP class, right? And so this class will be referred back to, and we're basically, it's sort of like object-oriented programming in a sense, where we've created the class, and now the Pseudowire class will refer back to the L2TP class in the dynamic sense. Here we actually block that out. So this is where we're doing the manual setup, but we're going to refer back to that New York v3 class a little later on in under the interface when we do our XConnect. Okay, so now we're going to go ahead and do our Pseudowire class, and we'll just call this New York Pseudowire. The encapsulation type, as you can see, we've got two choices, L2TP v3 and v2, so we're going to do L2TP v3. And the next setting is going to be protocol, and you can see the difference here. If we look up here, I use the exclamation marks here to comment this out, but as you can see, this with the dynamic configuration, this was the statement that we had, where it said the protocol that we're going to use is going to be L2TP v3, and to refer back to the New York v3 class to inherit these attributes, right? And so again, we only had authentication and password in here with the dynamic setup. So here we're not going to set this. We're not going to declare the protocol to be L2TPv3, we're going to say protocol, and if we say none, what it means is no signaling, use manually configured sessions. So as soon as I say none, now we're on the hook to do the manual configuration, and that's what's going to take place underneath the XConnect statement that we set up under the interface that we've chosen to designate as the Pseudowire interface, where we're going to create that Pseudowire connection for our L2TPv3 tunnel. Okay, so we've done protocol none. We're still going to do the IP local interface, which is loopback 44, and then we're going to exit out. All right, so now we're kind of into the meat of the configuration here, where what we're going to be doing is we're setting up the XConnect statement, but this is where we are going to declare all of the variables that we're using as part of this session. So we'll start out with XConnect, and we're going over to 6.6.6.6. And again, the virtual circuit ID is going to show up here, but we're going to manually identify the ID, the remote ID, and the local IDs as well. So the encapsulation, L2TPv3, and this is where we say manual. If I do a question mark here, you can see that if there was a Pseudowire class that I had was going to refer to, which we do here in a second, I could put that in here, but we're going to say manual. So I'm manually going to configure my session parameters, right? And then I put the Pseudowire class in, and I'm going to refer back to New York Pseudowire. We'll hit enter. And so again, by defining the Pseudowire class as New York Pseudowire, it's going to look at these values and use these values that are listed here for its configuration. All right, so now I'm going to set my L2TP ID, and this is very critical. So 426 and then 624. So why am I choosing 426 and 624? And I'm going to go ahead and hit enter here, and I'm going to bring my pin out real quick. So the 426, this guy right here, is the local ID for the session, for the L2TP session, and the 624 is the remote ID. So what I'm saying is 624 will be the local ID there, and 426 will be the local ID here. So when I do a show L2 tunnel on R4, I will see that the 426 is my local ID, and I'll see 624 as the remote, and then vice versa. It'll be just the opposite when I run the show L2 tunnel command here on R6, right? So we're manually defining what these values will be. When we did our video yesterday, you should have noticed that we get random values, or we got random values. Today we're hard coding those values in here, and that's what's going to show up, and we'll see that. So basically all I'm saying is the local value, and you could use any number here. You could have said, you know, 42671, right, or 33 or 66. It doesn't have to be 426. The reason I chose, and let's scratch this out here, the reason I chose 426 is because it's router 4 going to router 6, and then router 6 going to router 4, right? Okay, so let's clear our screen off here, and let's go back to the cursor, and let's drop back in to our configuration here. And remember, the key is that these values need to be reversed on the opposite side over on R6. All right, now we're going to set our cookie values. So cookie, and let's do a question mark here, and you can see the L2TP local cookie value and the remote cookie value. So we're going to set both. So the first is going to be the local, and if I do a question mark, you can see, is it a 4-byte cookie or an 8-byte cookie? So I'm going to go ahead and say we're going to do 8-byte cookies, right? Oops, sorry. And then the low value, and so I could just simply set whatever the low value is going to be. So on this one, we'll just set 44, right? So if I do L2TP cookie remote, we'll do 8 bits, and then again, the low value, and we'll just set that to 66. As you can see, that value climbs very high. All right, so we've got our local and remote cookie values, and finally, we're going to do our L2TP hello. And when I do the question mark, you can see the L2TP class name. So here is where we refer back to the New York v3 class, And as you can see, we're just setting it so that it'll look back into this class to find out what the hello values are. Okay, so we've got that set up. If I do a no shut, we're going to bring that interface up, and then I'm going to exit out. And so the OSPF configuration from yesterday, in addition to the crypto configuration, let me go ahead and slide that up right here. So here's where we're at right now. And this is the rest of the configuration that we need to run, because I'm going to go ahead and drop IPSec on top of everything. So I'm going to go ahead and copy this, and we're going to drop this in here right now. And it drops everything on there, and then it finally saves the configuration for us, turning ISACamp on. And so again, you can refer to this here. We did the crypto map setup yesterday. And the purpose of this video really is to walk through the manual setup of the L2TPv3 manual mode. All right, so if I do a show L2 tunnel, as you would expect, it shows it's waiting for the tunnel. But something to keep an eye on here, right? So here's the local ID, right? And there's that 426, so we had that 426 right here. And the remote ID is 624. And so those were the values that we configured. You can see we still see our virtual circuit ID of 99, right? And then the tunnel ID is a random number, and we did not set this. Okay. All right, so let's go ahead and jump over to router 5. And we're going to do an extended ping like we did yesterday. So we'll do ping IP to 192.168.1.254, and we'll do a randomly high number there. And as you would expect, router 6 isn't even configured yet, so we're going to receive no love here from router, or we're pinging over to router 7. So router 7 can't get back over to router 5 because the tunnel's not there. All right, so let's jump on to router 6. As you can see, router 6 is the default setup. It's been completely wiped and reloaded. And so we're going to go ahead and do each step. We're just going to copy and paste here so that you can see. So we'll drop in the initial config for the interfaces, right? We're going to drop in our San Diego L2TP class. So make sure I get that L there. All right, and again, as you can see, we're setting make sure we exit from that. All right, so we're going to drop in those settings. And so what we've did again, we've got the retransmit initial retries, we've got the retransmit retries, retransmit timeout max, the cookie size is to 64-bit, right? And our authentication is just simply Cisco for the password. And so we exit it out there. We'll come over here, we'll grab our Pseudowire class. And again, you can see that the Pseudowire chooses protocol none. And this is commented out here. That's what the exclamation marks are for. So it's not taking that as a command. So it just says protocol L2TP v3 San Diego v3 class. That's what we use for the dynamic setup. Here we're saying protocol none, which is going to then make it mandatory for us under this interface FA01 to set all the configurations. And actually, let me change this to 8 bits here. Or I'm sorry, 8 bytes, 64 bits. So we'll grab this. And we're now going to drop in this configuration information here. Oh, whoops. Copy that. All right. So now we're creating the Pseudowire with the Xconnect statement here, right? We've got all of our IDs. We've even got the IDs reversed, right? And if that's not reversed, and maybe we'll change it and see what happens. But if this isn't reversed, the tunnel, the Pseudowire is not going to instantiate correctly. All right, so we've got the rest of our information there for our cookie sizes. And again, a lot of these you can go ahead and set a value for, right? But some of them, like the retransmit retries, only if I want to change it do I need to put something in here. Same thing, retransmit timeout max. If I don't need to change that for some reason, if I'm not going over, you know, for what a really slow line or something like that, where maybe it's frame relay, legacy, 64K line, and you're going across the country, which is almost unheard of today. Typically, again, the dynamic configuration will suit your needs. All right. And then last but not least, we've got our OSPF configuration and our IPSec configuration. And we'll drop that in here now. And that's everything in terms of the configuration. So if I were to jump over to R5, you can see that we've got nothing going on R4. If I do a show L2 tunnel, right, it shows waiting, because we're probably going to be waiting for the tunnel to come up, waiting for the crypto to create the security association. It says established. I jump over to R5. We're still waiting, and then look at that. Magic. Fantastic. And there's our EIGRP neighbor adjacency between R5 and R7 that has also come up now. And we've got connectivity, right? So this is basically a quick walkthrough of manual L2TPv3 configuration, and we've once again secured that configuration with IPSec. I highly recommend, if you're interested in a lot of the internals, to take a look at RFC 3933, which is your layer 2 tunneling protocol v3. It is chock full of some incredible information and really goes deep into the weeds on all of the internals of L2TP v3. It gives you some of the historical information on L2TP v2, and we've got connectivity. So if I take a look here, you can see the remote ID 624, the local's 426, tunnel ID 9105. Let's go over to R6, and if I do a show L2 tunnel, let's see what we see. Sure enough, the local ID here is 624, and the remote ID is 426. All right, so what happens if those don't match? Let's see if we can confirm that that is going to, let's see, IP int brief. Let me make sure I know the, show IP int brief. Sorry about that. All right, so we're going to go into do show run int fa01. All right, and that is where we have our ID. So if I go into int fa01 and we drop in the xconnect command here, and I copy and paste this in, if I were to now do no L2TP take these IDs out, right? So if I remove the IDs, what effect does that have on my tunnel? So it shows the tunnel is up, but will the tunnel stay up? And so we're going to wait and see whether or not the pings successfully continue to go through, or if they stop. And probably when it signals next, we're going to see that that tunnel is going to drop down. So we've got our pings going. So we're here. So let's do a do show run int fa01 to confirm. And as you can see, it says incomplete L2TP manual config. And the reason it's incomplete is because we've removed the IDs, the L2TP IDs on the local and the remote end. So if I were to take a look back on R5 here, our ping is still going. And we're probably going to have to wait for this to sort itself out to see, or for it to figure out that we've got an issue with the tunnel. So on R6, if I do a do show L2 tunnel, you can see that it also sees that the tunnel is still in an established state. And so let's also do a do, and we're going to debug, and it's going to be, trying to remember, VPDN, and oops, VPDN, here let me do that on R4. I don't want to jump out there. So this tunnel is still established. So if I do a debug, VPDN, and it's going to be L2x-events, and I think that's it. So we've got layer 2 protocol bugging on for the events, right? So we can see the tunnel ID. You can also see the control channel retransmit delay, right, going back and forth. Let's go ahead and take a look at the show L2 tunnel now. See what we see. Still shows established. It's still up, right? It hasn't dropped off yet, even though we have an incomplete config on the other side. So our connectivity is still good. And we'll come back over here to 6. And here's what I'm going to do. I'm going to go ahead and mismatch intentionally. It doesn't look like the tunnel's going to drop out on us anytime soon here. So I'm going to actually put some bogus IDs in here. And we're going to set the L2TP IDs to 24 and 26. So now if I do a do show run in FA01, you can see that the configuration is now complete. We're not receiving the message saying that it's an incomplete config because the IDs are here. If I do a do show L2 tunnel, right, you can see that the old IDs are still in there. So the tunnel has not come down yet. Even though we've switched the IDs in the middle. So we'll give it a couple seconds here to see if in fact those values change in the control packets that go back and forth between the two, and it's what we call LCCEs, which stands for L2TP Control Connection Endpoints. And so when you take a look at the RFC, you would see that this would be considered an LCCE, and R4 would be considered an LCCE as well. And again, it just stands for Layer 2 Trunking Protocol, or I'm sorry, L2TP Control Connection Endpoint, right? L2TP Control Connection Endpoint, because this is where the L2TP has been configured and is controlling the endpoints. All right, so let's clear that, and let's see if this is going to break down and going to cooperate with us. So it still hasn't. So what we could do is I'm going to go ahead and type end, and oops, we'll go back in here in FA 0/0/1, and we're going to say shut. So we're going to shut that interface down, and we'll see what happens. We'll get our ping going again here. All right, and as you can see, we shut the interface down. The tunnel went down. So if I do a show L2 tunnel, we still see that it's established here. However, it's just that it hasn't timed out yet, right? And from yesterday's video, we know that if we wait, right, we've got our retry set on here, and our timeout values are set on here as well, that this is eventually going to go down. So what we're going to do is we're simply going to bring up that interface and do a show L2 tunnel, and you can see we shut the interface down and brought it back up. So that has resulted in the values that we put on that interface for the L2 tunnel ID, the local ID and the remote ID, they are now different, and you can see it says that it's established. And we need to make sure that those values are the same on each side. So let's look over here. So we've got some different values here. Let's check the ping, right? And what's interesting is that we still don't have any connectivity. So this is a very interesting use case. So we're looking at the show L2 tunnel, and if I'm looking here on router 6, I'm seeing, hey, this is established, right? This is showing me that the tunnel is established. The tunnel ID is 4264. I have my local ID and my remote ID. If I jump over to R4 and do a show L2 tunnel, you can see we've got the local ID and the remote ID as they're set here on router 4. and it shows that it's established as well. However, R5 cannot reach R7. So even though the state of the tunnel is showing as up right now, it's clear that no traffic is transiting that tunnel because these pings are unable to get through. What if I try to go from R7 over to R5? And so let's do a ping. And we'll do a random number of pings here. So let's see if we have any connectivity from R7 over to R5. And as you would expect, excuse me, we do not. So this can be a little misleading, right? You see that statement that says that those IDs have to match. However, if you were to look at this, you would say to yourself, well, wait a second. The state of my tunnel is established. That's what I see when it's working. It's established here, and that's what I see when it's working, right? However, we've got no connectivity between R5 and R7. Okay, so let me go ahead and do a do show run int fa01, and let's solve this here by saying no, and then we'll do oh, I'm sorry, I have to drop into the X-connect there, sorry about that. So now let's go ahead and do no L2TP ID 2426, and we're going to pull it back up and say, and we're on router 6, so it's going to be 4 to 6 and 6 to 4. So let's put those values on there now. Are we having any luck here? Not yet. So we're going to wait it out here a little bit, see if this automatically comes back up, or check to see if what we have to do is take the interface down and then bring the interface back up. And that should do it automatically. I'd like to see the results of whether or not it's going to happen here auto-magically for us when the control messages are going back and forth. And so again, show L2 tunnel here. And on R6, if I do a do, or let's exit one level up, do show L2 tunnel. And you can see the IDs have changed, right? They changed automatically. We didn't have to take the interface down, and look at that. We now have connectivity between R5 and R7, and again, our neighbor relationship has reestablished. So if you're doing the manual configuration, keep in mind that there are a number of intricacies that you need to be aware of, that if you misconfigure, it may show that, hey, the tunnel is up, it's established, however, you're not able to pass traffic across that tunnel. And that L2TP ID is definitely one of them, definitely one to keep your eye on. As you can see, it sorted itself out here. Once we made the change, we didn't have to shut the interface down and then bring it back up. And then R5 and R7, their adjacency with EIGRP and their connectivity has been reestablished. All right, so that wraps up the third and final video for L2TPv3, at least the with the Ethernet Pseudowire encapsulation type. So I'm going to go ahead and do one with the 802.1q VLAN for another use case. But this is a great example of how you can do manually, how you can manually tweak some of these settings. And again, 99% of the time, the dynamic settings are going to be sufficient. But if for whatever reason you're in a legacy environment and you've got some serious bandwidth considerations or latency considerations that you're facing, it may be required for you to sort of dig down into the RFC or to dig down into the config and to manually set the L2TP configuration settings so that they're going to work a little bit better in your environment. It gives you a little more granular control. All right, so that's it. We've done a number of things with L2TPv3 in the manual mode here, and we've also got IPSec running on top of everything. I hope this video tutorial has been helpful for you. I hope that maybe at some point you get to use this and that it's of value. All right, have a great day and best of luck out there on the wire.